So we have discussed like what is spring force. I think it is clear to you. F is equal to minus kx. What is x? X is the extension. And x is, we can say, it is the displacement from the mean position. Displacement directions from initial to final. Clear? Now we will start with the properties of, right on, factors affecting spring constant. I think you can write this point also first. Direction of spring force. Spring force is opposite to the opposite to extension in spring. Clear?
Okay.
After this, write on the heading. Factors affecting spring constant. What are the factors? Write down factors affecting spring constant. Spring constant. Constant means K. I'm talking about this.
Okay.
Write down. First is first is spring constant, or we can say it depends on it depends on type of string, type of material, type of material. It means K is directly proportional to the strength of material. For example, you are taking copper. Copper has different K, aluminum has different K because they have different strength of layer.
Yes, yes.
It depends on type of material. Clear to you?
Yes, yes.
Next point, write down. K is inversely to the length of the spring. For example, if you cut, you are, if I ask you, this is the spring, clear? Its length is L naught. Let us suppose. Spring constant is K, length is L naught. Natural length. Clear? If you cut this spring into N parts, three parts, let us suppose three parts, like this, like this. First part, second part, third part. Clear? Like this.
Okay.
This is L naught by 3. Clear? This is L naught by 3. This is L naught by 3. Clear? So I want to know what is the spring constant here, because one question I want to explain you. If the spring is big, length is big, clear? You can easily break this. But if you're taking very small length of the spring, it is not easily breakable. You can do the experiment also. If the spring is very large, you can break it. But the spring is small. It is not easily breakable because natural this length of the spring is less than more k. K is more concept.
Okay.
Now my question is, what is k dash here? Spring constant. Now length is L naught by 3. Since we know k is inversely to the, if you remove the constant, one constant will come. You can take alpha. Clear? Equation 1. For this case, for this spring, I'm talking. Let us suppose spring constant is k dash. Constant remain alpha and length will be what? L naught by 3. So if you look at carefully, it will be 3 alpha by L naught. And what is 3 alpha by L naught? It is 3k. Clear?
Okay, sir.
Spring constant here becomes 3k. Here also 3k. Means it is inverse to the reciprocal of the length. If length is L naught by 3, spring constant become 3k. If length is L naught by 2, spring constant become 2k. If length is 2L naught by 3, it is 3k by 2. Like this. For example, if I ask you, you will solve this question. You have a spring, clear? The spring length
Okay.
is L naught, and you are breaking this spring into 1:2 part. 1:2 part. Then what is the value of spring constant here? Length is L naught. You are breaking into two parts. 1:2. Clear?
Okay.
First of all, find
Yes,
the length here. You can break L1 here. It is L2. Clear? So they have mentioned like L1 by L2 is what? 1:2. Clear? If L1 by L2 is 1:2 means if I ask you L2 will be twice of L1 and this total length L1 plus L2 is what? Simply L0. Clear? So L1
yes.
plus L2 is 2L1. If I ask what is L1, L1 becomes L0 by 3. Clear? If L1 is L0 by 3, then what is L2? 2L1.
2 L
2L1
naught
means 2L0 by 3.
3.
So here length is L1 is L0 by 3. L2 is 2L0 by 3. Then if I ask what is the spring constant here? Reciprocal of length. Clear? Reciprocal of
Oh,
length. This K dash will be how much? Reciprocal of length, that is 3k. And what is here?
3 by 2.
3k by 2. Clear?
Okay.
Clear to you? This is the property of, you can check 3 times it becomes. If you decrease the length L0 by 3, clear? Then
Yes,
spring constant become 3k. Clear?
yes, sir.
Next property is you can write, just a minute, no. You can write third property. K is directly proportional to the r to the power 4. What is r? Small r, I will tell. Let us suppose this is the spring. Clear?
Okay, sir.
And if you observe carefully, if you observe carefully, uh, if you observe carefully, this spring has radius. This spring has some radius. Clear? This is r. Clear? And
Okay,
this
sir.
end of the spring, if you zoom it, if you zoom, you will find the end of the string is simply circular. Like it has some radius that is smaller. Clear? This
Okay,
R
sir.
is what? It is spring is cylindrical shape now. Like this. Clear? I'm not talking about the radius of the spring. Clear? And
Oh,
spring is string. Clear? String part. This end. It is circular. A small r. Clear? Again I will draw this circular end. Okay? Zoom it. So it is small r. Clear? Its property. So what is r? R is the, you can write radius of spring. Clear?
okay.
What is small r? You can write small r is radius of
Thickness.
wire or string, or you can say wire.
Okay.
Rope, wire, anything you can say radius of wire.
Okay,
Okay.
sir.
So this k is directly proportional to the r to the power 4. Next property you can write k is k is inversely to the 1 upon r to the power 3. Clear? One more property. What is R? R is radius of spring. Clear? If you merge all these points, then K is what? K, you can write K is directly proportional to the R to the power 4 L naught R to the power 3. And if you remove this proportionality constant, it will be C R to the power 4 L naught R to the power 3. This is the formula of K. Clear? So spring constant depends on first types of material, radius of the wire, radius of a spring. Clear?
Yes.
Length of the spring L naught. L naught is the length of spring. That is natural length. Understood? Spring force, because basics. First, you should clear your basics. After knowing the spring
Okay.
force, then I will move to the nuclear force. You are not going to do PhD again. I am saying you should learn the concept. It is there. Okay, you should learn how to apply. That is the first and utmost demand of learning physics. Clear? So write down
Okay.
next. Have you written this?
Sir, what is the constant C, sir?
Constant is simply like material, types of material. Clear?
Okay, sir.
Simply types of, because I didn't write strength of material now, first point. That was C, simply the types of material. Clear? You can write
Okay.
now what is strength of material means simply if you take steel, if a spring is made up of steel and one spring is made up of rubber, then which is having more strength? Which string, which spring you can easily break? Clear? Steel you can't break easily, but rubber you can break. Rubber wire you can
Oh,
easily break. So understand the K directly proportional to the strength of spring. And F is equal to minus Kx. More the K, more is the spring force. Understood?
yes, sir.
After this, write down nuclear force. Nuclear, nuclear force. You can write down the heading. Nuclear force. Clear? Now, what is nuclear? First of all, we will understand what is nucleus. Inside nucleus, what is there? Nucleus. Nucleus. Clear? Inside nucleus, what is there? Protons and neutrons. Protons plus neutrons. So nuclear force is nothing. It is simply the force that is responsible for the stability of nucleus. Clear? Within the nuclear radius, it is acting. It is the force between proton and nucleus. Clear? Understood? It is simply for
Yes.
the stability of nucleus. You know, nucleus, you have learned in chemistry and physics. Why it is stable? Because of this nuclear force. Clear? You can
Okay.
write here also like it is a force between proton and proton and proton. Clear? It is a force between neutron and neutron. Clear? Proton and neutron. Fourth, neutron and proton. Meaning is same. If you talk regarding like if you talk about me like proton, you should say, sir, it is repulsive in nature. But no, it has nature is, it may be repulsive, it may be attracting. Clear?
How, sir?
Understood? It is by nature. It is by nature like proton. Listen, electrostatics in class 12 you will learn plus repel. Clear?
Yes.
Plus minus attract. That's what you have learned. But inside nucleus, what is happening? Because of this proton and proton, it will repel because of electrostatic force. Then nuclear force because of mass effect you will learn, because I can't say much, because this topic you will learn more in class 12. Because of mass effect, this nuclear force develop, and this will keep these nucleons means protons and neutrons within the small space. Because of this force, it is binding together. Clear? That's only I
Okay,
can
sir.
say. Clear? So proton, it is attractive in nature. Clear? Simply clear? Any doubt? But gravitation force is also attracting in nature. Nuclear force is
Sir,
also attract. Yes,
only now, sir.
yes. Are you asking something?
Sir, proton will repel each other, no, sir.
Yeah, proton is repulsion. That is, you have learned in electrostatics. That is electrostatic force. Coulomb's law. You will learn class 12th. You please tell me. This is the nucleus, okay? Inside nucleus, protons are there, neutrons are there. Clear? Then what will happen?
Okay.
This proton will repel like this, very huge force. It will repel like this. Now, you please tell me. Then this nucleus never be stable. Then who is making this nucleus stable? Even they
Neutron.
are even they are applying repulsion force on each other, but this nuclear force is dominating the. It's very strong. Nuclear force is very strong as compared to this repulsion force, that is electrostatic force. This nuclear force is very strong and it will hold these nucleons together.
Okay, sir.
Clear? And why it is so? No need to go in PhD because you will learn in class 12. Clear? So you can write
Okay,
here
sir.
also nuclear nuclear force is a force. Nuclear force is a force which which acts between nucleons nucleons and responsible responsible for the stability of nucleons in chemistry.
Sir,
In chemistry you have learned nucleons. This term I think not new for you. Nucleon
no, sir.
simply
Well,
means nucleons
nuclear.
means proton and neutron. Okay, we are saying togetherly nucleons. Okay,
Okay, sir.
have you written this?
Ah, yes, sir.
Okay, now write down properties of. Just 1 minute. Write down properties of nuclear force. Properties of nuclear. Just learn this. Okay, experimentally. Okay, everything. Write
Okay.
down. First is it acts between nucleons that between nucleons irrespective of their nature, irrespective of their nature. Meaning is what?
Sir, irrespective of the electrostatic force, it will act also.
Nature means, for example, it acts between nucleons irrespective of their nature. It does not depend on nature. Clear? Whether it is proton, neutron. It remains same. Clear? Force between proton, nuclear force between proton and proton is same as nuclear force between proton and neutron. It is same as between neutron and neutron. Meaning is that. It does not
Okay.
depend on the nature. Nature means it does not the partiality. Whether it is proton, proton, whether it is proton, neutron, it is neutron and neutron. No, it remains same. Whatever nuclear force in between the proton and proton, it will be same in the proton and neutron, neutron and neutron. Clear?
Okay.
Any doubt?
Yes, sir. Sir, then irrespective of the nature means irrespective of electrostatic force, sir.
Actually, I'm not able to know. Could you please again say?
Sir, irrespective of the nature means irrespective of the electrostatic force between
No,
proton
no,
and
no.
proton.
Irrespective of the nature means like proton, 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 neutron, neutron, neutron means everywhere. In between them, force, nuclear force is F. Here also F. Here also F.
Okay, sir.
Clear? Second point, write
Okay.
down. Write down. This force, you will learn this, okay? The second point in chemistry more. This force depends upon, depends upon spin motion. You know spin motion, chemistry you have learned?
Spin of electron.
Yeah, like I think you have learned in one shell. It is like this. This is spin. Plus half, minus half.
Yes, sir. Learn, sir.
Clear? This force depends upon spin motion, full stop. Nuclear force, clear? Nuclear force between nucleons, nucleons having same spin, having same spin is stronger than stronger than nuclear force between nucleons having opposite spin. Clear? Having opposite spin. Clear? Meaning is what? If the spin is two nucleons, clear? Two nucleons having same spin. Clear? Then,
No.
for example, proton, proton, same spin, plus half, plus half. Then more, this is very, very strong in that condition. Clear? Spinning means like this. One is moving clockwise, plus half means clockwise, minus half means anti-clockwise. Spinning. Rotating on its axis. Clear? Like this. Electron. So, if the nucleons having same spin, if the spin is same, then nuclear force is stronger. More stronger than the
Sir,
nucleons having
have
opposite
you
spin. That is
electron?
concept only.
Sir,
Clear? Experimentally, it is observed that nuclear force between nucleons having same spin is stronger than the nuclear force having uh, opposite spin.
sir,
Experimentally.
is it about the spin of electrons or spin of the nucleus?
Electron is not in the nucleus, okay? Proton in the nucleus. If proton is moving like this, and one more proton is moving like this, spin is same, clear?
Sir,
But here one proton is moving like this, one proton is moving like this, opposite spin. Then in this condition, the nuclear force is very, very strong rather than this. Concept
sir,
simple.
we have about spin of protons. Sir.
That is concept clear. If, for
Oh,
example, objective question we are asking like if two protons having same spin and two like proton have opposite spin, then in which case nuclear force is more? That is same spin.
Okay, sir.
That is concept only. No need to go in depth. Okay. You should learn. I am
Okay,
saying now. Don't do PhD. Simply learn because it all things are experimentally observed. Gravitational force, everything is experimentally observed by Newtons. Similarly, some scientists like nuclear force came and they have observed these things. These things are happening in the nature. Nobody know many things like happening in our nature. We are simply doing the observation, physical study. We are doing. We are not
so,
because many things are still on our earth. We don't know many things, but still they are happening. Clear? Few things like
okay.
it is experimentally proof. Few things are we are learning. It is so. It is universal, like universal constant G. It is universal, like we are learning. Why it is G? So we do. We are not bothered regarding. Clear?
Okay, sir.
Next, you can write next property. Third property you can write nuclear force may be attractive, repulsive, or zero. We will learn this chapter in depth. Reason is that entire mechanics is depending on that. Vector, clear force and laws of motion. Very, very important chapter. Center of mass, rotation motion. Those are very easy if you understand this force and laws of motion. Clear? Rest of the
Yes,
chapters are depending on this. Clear? So the next
okay.
point you can write nuclear force. Nuclear force is a short range force. Is a short range, short range force. Short range, you understand?
Yes, sir.
It means you can write here it is considerable. It is considerable up to separation less than equal to 10 to the power minus 14. Here it means what? If the separation means simply less than 10 to the power minus 14. If it is more than that, here nuclear force is zero. Clear? Suddenly drops zero. Clear? After 10 to the power minus 14. That's why it is short range force. Now very, very small space it is acting. Clear? Clear? Understood? 10 to the power minus
Yes, sir.
14 meter. Very, very small range. Clear?
Okay.
Understood? Right on
Yes,
next
sir.
point. Nuclear force. Nuclear force follow principle of principle of saturation. What is this? I will explain.
Okay.
First off, if we if we increase the number of nucleons, if we increase the number of nucleons, if we increase the number of nucleons, you can write comma. If we increase the number of nucleons, comma, nuclear force, nuclear force increases, nuclear force increases and then become constant, and then become constant. Clear? Meaning is what? If
Okay.
one proton is here, clear? If you add more proton nearby this, like this, then nuclear force will increase, clear? Like this. If you increase the number of nucleons, then nuclear force will increase now.
Yes, sir.
You are increasing, clear? Then
Sir,
what
can
will
you please
happen?
slow? I am writing.
Okay, backside now. Okay, okay. So here, if you increase the number of nucleons like this, then what will happen? If you take
Sir,
one more nucleons, then it will not increase.
sir,
If we increase the number of nucleons, nuclear force increase and then become constant. Why? Because the range is very short. Clear? If we are taking this only, center nucleons, it is proton, one proton. It will apply force on this, like this, nuclear force increase, more proton, more nuclear force. Clear? More nuclear force, more proton, more nuclear force. Because of single proton, there is one nuclear force, F. There are many protons, then nuclear force will increase. Then it will increase up to a certain level. Otherwise, if it is increasing continuously, then nucleus themselves damage or destroy. Clearly, obviously, if you increase the cloud of nucleons nearby one proton, then it will increase its concepts up to a saturation level. Then it become constant.
sir, can you please slow the previous line?
Sure. You can write.
Or
Simply understand nuclear force is nothing. It is a force between two protons, proton, neutron, neutron, proton, neutron, neutron. Clear?
okay.
If you increase the number of nucleons, it will increase up to a certain level and then become constant. Saturation. It will attain saturation value. Saturation means maximum value of nuclear force.
Okay.
Clear?
Sir, completed writing this, sir.
Okay. Last only weak force left. Then this entire force chapter is finished. Types of force we have learned in such depth. I think last is only. It is only you should learn simply in short only. Last is weak force. Write down. Next is weak force. Write down. It is a force. It is a force which act inside nucleons. Clear? That is different force. Weak force inside nucleons means within proton itself, which act. It is a force which act inside nucleons and responsible for responsible responsible breaking of nucleus, for breaking of nucleus. Why nucleus? Well, nuclear bomb. Clear? Like nuclear fission reaction, you will learn later in class 12. Nuclear bomb, atomic bomb, clear atom bomb. So what is happening because of this weaker force? Because of this weak force that is acting inside nucleus, means within the proton. Because of this force, this proton, this proton is converted to this proton is converted to neutron. Clear? By
Okay, sir.
releasing some particles at positron like this.
Sir, your proton is getting converted to neutron, sir.
Yeah. Proton converted to neutron because of this weak force. Neutron converted to
Okay.
proton. So this conversion is only because of this weak force. Understood?
Yes, sir.
So I can show you also like what is it is no actually positron. Okay, you can write also if you wish. Beta decay or positive. I will write. It is positron. Here I should write. I should take nuclear. This is simply positron. Here I think it is beta decay. I will show you that. I'll show you that. Wait. Have you written this?
Yes, sir. Sir, I wrote, sir.
Okay, wait. Give me 1 minute. I will share my screen. Okay, you just look at all the things. Look at here. Can you please check? Can you check this?
Yes, sir.
This electron, one particle, can you check? That is antineutrino. With positron 1V, I have drawn like this. That is neutrino. In our slide, you can write. Is my screen visible to you? This?
Yes, sir. Visible, sir.
So you can write here. Okay, I didn't write actually. This is neutrino. That is anti. I think this is antineutrino with electron. You can check here. With electron, it is antineutrino. So always remember this. This particle, they antineutrino name. This is I think neutrino particle.
Okay.
Positron. This is negative beta decay also. I will show you. So can you check showing like my screen visible?
Uh,
So you can check. You can check this. Is it visible, Dinesh?
yes, sir.
You can check this carbon 14. This nucleus. Okay, it is going to convert
Okay.
into nitrogen. Here, one
Okay.
electron it is going to lose. Initially, it has 6 proton, 8 neutrons. That is 14. 14. Here,
Okay, sir.
nitrogen. Beta minus. Beta minus means negative beta decay. Clear? Beta plus means positive beta decay. With a positron, this particle is neutrino. Clear? I think you understand this. Can you check this?
Yes, sir.
This neutron is going to convert into proton by releasing 2 particles. One,
Sir, carbon 10 converting to boron 10, giving of
uh,
neutrino and what?
can check carbon is converted to nitrogen. This is a reaction or nuclear reaction, okay? Don't go in that.
Okay,
You
sir.
should understand. Look at here. This neutron. Yellow is neutron. One electron it eject and one anti-neutrino particle. Before converting to proton, it is ejecting what? Release this wave. Can you see this wave is like that? Wave. That is energy. That
Okay, sir.
anti-neutrino is nothing. It is an energy. This is the energy
O-
like after during explosion. This energy is going to harm or it is going to do explosion.
Sir, then it
Okay?
is not a particle.
Antineutrino does not, it is massless particle, you can say. It is photon-like energy particle.
Okay, sir.
Here, electron has some mass. You can say antineutrino, I don't think it has mass or not. I will check also because I am not sure. Anti, I think it is massless. Mass of, let me check. Mass, we can confirm. Okay. Mass of antineutrino, we can check. It is very less. Here,
Okay.
1.6 means it is massless, very less. 1.6 multiplied 10 to the power minus 33 gram. Here, very less one mass. That is, I am saying massless almost. So, anti-neutrino, it's nothing, it's the energy particle. Energy. You can check here, like this. This is a reaction. Check. Four fundamental force, I have discussed this. Understood?
Yes, sir.
One is electrostatic force. One is weak nuclear force. One is nuclear force gravitation. Here, check. Here, understood?
Yes.
I will show you like, sorry. There. You can check this. This check. This is nuclear force. Clear?
Okay, sir.
You will learn binding energy, all this concept into class 12. हेलो हाँ वो
Sir,
करता हूँ मैं ऑफिस वर्क में कर काम में लगाता हूँ ऑफिस के थोड़ा कल स्कूल हाँ भी हाँ करता हूँ थोड़ी क्लियर
yes, sir.
चेक दिस sun in our sun the reaction is fusion reaction nuclear fusion reaction because of this hydrogen combined it is forming helium enormous amount of energy is going to release that is why sun is still but I don't know like from where hydrogen is coming to sun till now we don't know many things like clear it is
Yes, sir.
under research we should do research okay yes, sir.
Okay.
That's true
Yes, sir.
imagination I think it is binding proton in the atomic. So I will stop the lecture today here. Just do one thing. Clear? You should revise this lecture, and tomorrow I am going to start free body diagram. Clear? Because it's very
Yes, sir.
important. Tomorrow lecture, not tomorrow. I think tomorrow no class because I have one class. So tomorrow no class. Okay.
Okay, sir.
Dinesh, are you understanding?
Yes, sir.
So I will tell like in Sunday I will take your class or not. I will schedule. Okay, no need to worry. I will take your class on Sunday, and I will
Okay, sir.
teach free body diagram. Clear?
Okay, sir.
Thank you so much, Dinesh. Take care. Bye bye. Good night.
Good night, sir. Thank you, sir. Bye.